13.2, so 13.1 we talked about Laplace transform, that's taking the integral and moving forward. On this table, we went from left to right. So basically when we apply the Laplace, we move in this direction. Apply Laplace. If you apply Laplace and 1, that's the integral of 1 times e to the negative st dt from 0 to infinity. And if you integrate, you get 1 over s. If you integrate t squared, you get 1 over s squared. We did a few of those, and you did that, some of that for homework. Now the inverse, you notice the inverse is going back in this direction. So you have to eyeball the right and kind of match which problem do I have, and this way I could go back. The only catch, you have to tell me what you're using. So we're going back on the Laplace transform from right to left. So use the table to find the inverse transform of the function. Alright? How do you do that? You apply the inverse Laplace transform, and that will be simply f of t. You're trying to figure out what did you integrate to get that. 3 over s minus 7. If I eyeball this, 3 over s minus 7, okay, I could see right there, s minus 7. There's a 3, I could really take the constant out. So, s minus 7, isn't that e? And look at that. If this is negative, that's positive. So it's negative 7, that's going to be 3 e to the 7t. And you need to tell me which of those properties to use. Use property number 4. So I insist on the homework and your exam for you to write property 4 clearly for me, so I know exactly what you're doing. And if we look at part B, if we apply the inverse Laplace transform, then I get f of t to equal, and let's see, twice, I know that's going to be an e, I just looked at it, number 4, let's look at 4 again. So it seems this power right there, the a, is the opposite of that. If this is negative, that's positive. What if that's positive? Then by 4, that would be negative 5t, and there it is, done deal. That's all you have to do. Now this table, in the beginning it's a bit messy, but you'll get the hang of it because we're doing the same thing over and over. How about if I look at C? So this homework is not going to take that long. Let me space those just a bit so you can apply. There we go. So if I apply the Laplace inverse on both sides, this will simply be f of t. And normally within one step or two I'm done. I'm looking for an s squared plus a number. S squared plus a number. So I do notice that s squared plus a number, that's not the first 3. Okay, is it a number or is it s? Because I see 2 of them. If I glance at it, it's a number. So if it's a number, I'm looking for 5. 5. I need, you see how s squared plus a squared, so those have to match. Whatever you square has to be there to move back. Well, I glance, I notice, wait a minute, that's not matching. First things first, what do you square to get a 3? Isn't that radical 3? So if I multiply by radical 3, doesn't that look like, so the 5 I'll drag up front, I don't need that. And if I write radical 3 over s squared plus 3, but you might be saying, wait a minute, where did radical 3 come from? Well, you could multiply by radical 3 and divide by radical 3 as well, right? So notice, I multiplied by radical 3 and divided by radical 3. Reason for that, whatever this is, this has to be the square of that for this to work, for you to be able to use 5. And if I look at 5, now I say, look, that's a 3, that's a radical 3. When you go back, that's the sign of whatever that is to the t. That is 5 over radical 3. The sign of what do you square to get a 3? And there it is. Now, if you're ever in doubt, you could move forward. You could do what you did on the first homework. Take the integral of this from 0 to infinity times e to the negative st, and you get the same thing. And here we used 5, so I'm going to insist on you labeling those. I'm going to space those a bit and make it better and come back and continue. Okay, we're back. Now I'm looking at the same deal, s squared plus a squared, but there's an s there. There's a variable. Well, 5 doesn't match, but 6 does. So s and s squared gives you a cosine and a number to square. So what do you square to get that number? Look, whatever that is, that's what the angle is. So what do you square to get 5? Isn't that radical 5? So if you apply the inverse Laplace transform, you'll notice that f of t must have been, so the cosine, what do you square to get 5? Radical 5t. And that's pretty much it. And what allows you to do that? You need to tell me what that is on the homework and on the exam. That is by 6. And if I go to number 7, well, the same drill. We're going to apply that on all of those. We got to get really comfortable with that table. Then f of t equals, and I'm going to try and eyeball, okay, I have the whole thing squared, the whole quantity squared. Well, that's definitely not 1 through 6. It's not 7 because there's a plus number. There is no plus number. I'm trying to eyeball where, okay, I see it right there. It's, nope, not really. I thought I did see it. I don't. Well, let me look closer. The whole thing squared. Oh, the whole thing squared right there. That part. So s minus a squared. N plus 1. If n plus 1 equal 2, then n equal 1. So n equal 1. I need the 1 factorial at the top. So since that's a 2, I need the 1 factorial at the top. There's 1. So the 2 I don't need. The 2 I take up front. And I'm looking at 1 over, okay, so that matches now. N factorial, which is 1 factorial. And what is that? That's going to be t to the n. So we said n was 1. So t to the 1, e to the at. T to the 1, e, the opposite of that. And is it that number? Yeah, it's just that number, whatever that number is. That's what you must have integrated to get that answer. And what allows me to do that? That's number 9. Oops. Again, you gotta tell me what you're using on every step of the way. Well, we're trying to match this part. Let's see, we're looking at s squared plus a number quantity squared. And there's just a number there. So, s squared plus a number, that's none of those. S squared, nope, it has to be squared. Okay, it's that one, that one, that one of those 4. So it's one of those 4. I notice again, I glance at it, so okay, it is s squared plus a number squared and a number up there. Not that one, there's no s, not that one. It's that one right there. It can be that one because there's an s squared there. It's exactly this. It's s squared plus a squared squared. It's s squared plus a squared. Perfect. So if I think of that as radical 5 squared, that'll work. But I need to match it. So it's 12. I need 2a cubed. Whatever this value is, I need the cube at the top. So I need 2 times that. I could take the 4 and I could say, you know what? The top is actually 2 times 2 radical 5 cubed. And when I apply the Laplace inverse on this, I'll rewrite this. I will say f of t is going to equal, I'm going to write this in 2 steps. I'm going to take this 2 up front. And now if I glance at this, I'm looking at 2 times the square root of 5. Oh, I didn't divide by that, did I? I took the 2. So do you notice the 4 gave me those 2's, but at this point right here, I need to divide by it because it was in there. There we go. Much better. And that is s squared plus 5 squared. And that would be 2 over radical 5 cubed. And what is that mess? This is by, was it 13 or 14? Actually, that was 12. 2a cubed, yep, that was 12. Sine the a is sine of a is radical 5t, minus a t, the cosine of at, that's 12, minus a t, a is radical 5t, the cosine of radical 5t. There you go. If you think this is messy, try and use the definition. Integrate this mess, and you would come to appreciate this very quickly. And there it is. How about this? How does G differ from F? G has an S at the top. It's the same as F. So if I look at F, so wait a minute. A number S squared plus a number S squared. Okay, it can't be those because they have S's. It has to be one of those two. It can't be that one because that has S squared. So that one. Again, I need to figure out what do you square to get that number first. Get that out of the way. So here, square root of 11 squared. Got it. So the top should be 2 times that number times S. So I need 2 times radical 11. Well, I can't just out of nowhere add a 2 times radical 11 unless I divide by it. So now when I apply the Laplace inverse, there we go. When I apply the Laplace inverse on this, I'm looking for f of t. I'm done. Equal. Now, the 1 over 2 radical 11 I could take out. And what's going to be left? Well, look at it now. I'm looking at 2 radical 11s over s squared plus 11. This is the square of that. That matches identically 2as over. That matches 13. That's t, the sine of at. By 13, that is t, the sine. What's taking the place of a? What do you square to get 11? Radical 11t. And there it is. So make sure you tell me what you're using on every step of the way. You can only use that table. Here I'm trying to look at this. I notice there's a shift squared, and that's 3 squared. Well, let's see. Something with a shift. Something with a shift squared. So it looks like it's one of those two. One of them has an S, one of them doesn't. There is an S at the top. Okay, the one with the S, I'm eyeballing 8. But by 8, those should have the same value. By 8, those should have the same value. Can't I factor a 5 out? I'll have S minus 2 over S minus 2 squared plus 9. Well, what if that doesn't match? That's coming up, don't worry. I'm leaving nothing out. I am going to take into account every different combination you can think of. So f of t is going to equal, and what is that? The 5 I ignore. I'm looking at s minus 2 over s minus 2 squared plus 3 squared, right? So if I look at, and it matches number 8, s minus a squared, and b. Okay, so what's a? That's the power on t, and remember the opposite. So it's e to the 2t, and what do you square to get a 9/3? That is the angle right there by 8. That's the cosine of 3t by 8. The cosine of 3t. Alright, a few more to go. Almost done. 3 more actually. And those I left good things for last. And I'm touching on every combination you'll ever come across. Okay, now what? Here I notice there is no quadratic. So I need to complete the square. If it factors, that's the next section. Isn't that s, let me see, s squared plus 4s, if you add and subtract, let's see, if you add half of the middle number, which is 2 squared is 4, and subtract 4. So that will give you s plus 2 squared, and if you take 5 minus 4, that's a 1. So now I'm trying to eyeball a number over s minus 4 squared, so let's see which one has that. A number over, again, those two are the only two with the shift. A number, it's that one. It's a sign. So I want those to be the same. S minus a doesn't have, unlike this. S minus a, no big deal, but those have to match. What do you square to get that number has to be up there. Well, what do you square to get a 1? That's 1. That's easy then. And why is that? Because then I could say, well, I could apply the inverse Laplace transform. The 4 I could take up front. And I'm left with 1 over 1. So b is 1. And a is a negative 2. So we're looking at 7 by 7. And the good news, only one of those match. It's not like one of you could use 7, one of you could use 8. That never works. So that's going to be, it seems, on 7, e to the at, e, the opposite of that, negative 2t, the sine or cosine. Number 7, the sine of, what do you square to get 1? 1t. Of course, you don't have to write the 1. I'm just putting that down for your notes. And the same deal with this. Again, I'm taking all combinations. I just worked this out in the previous problem. So that is s plus 2 over s plus 2 squared plus 1. So now I'm glancing at not 7. Now I'm glancing at 8. 8, the shift has to be the same. By 8, the shift is the same. So I could apply Laplace. Again, what if the shift is not the same? Well, I'm glad you're asking. That's the next example. Then f of t is going to equal, we said, by 8. E to the negative 2t by 8. E to the negative 2t. The sine of what you, the cosine, that's the square, whatever you get that. What do you get? The square of whatever you get, 1. What do you square to get a 1? A 1. So that's so cosine always have an s, sine doesn't. So we're trying to work backwards. What did you integrate to get this? And the last problem, that's where things don't match. And that one, oops, I forgot f of s. Forgive me. All the excitement. So this is gonna be 2s plus 1 over s squared plus 4s. Half of the middle number is 2 squared, you get a 4. That is, of course, I'm supposed to work downwards, but I wanted to see this in one line. That is s plus 2 squared plus 4. Well, we have an issue. If there's an s, I just saw it. If there's an s, I need that to match s minus a. But it's not matching. So what I do, I use algebra. I need this to be s minus whatever that is, s plus 2. There's a plus 1. Doesn't that mean that I really added a 4? To keep this equal valid, don't you need to subtract a 4? So think about it. If I distribute that in, that's 2s plus 4 minus 4 plus 1. That's 2s plus 1. Right? Over s plus 2 squared plus 4. So I really got f of s to be 2 times s plus 2 over s plus 2 squared plus 4 minus 3 over s plus 2 squared plus 4. A small price to pay. Now does it match? If I glance at 8, it matches. S minus a squared and s minus a, it matches right there. There's a 2, that's not a problem. But here, this piece, this really looks at 7. 7 says s minus a is not a problem. You could leave that alone. But those have to match. That is, if you look at 7, what do you square to get that number that should be up there? What do you square to get 4? A 2. So I need a 2 up there. Since there's no 2, I add a 2 and subtract a 2. And let's glance how this works. I am going to apply the Laplace inverse on both sides. And I'm going to get f of t to equal. I'm going to write this in 2 steps. I'm going to take the 2 out and apply the Laplace inverse on s plus 2 over s plus 2 squared plus 4. I'll put that in parentheses. Minus 3 halves. So I'm going to take the 3 and the 2. And notice now that matches number 7 identically. The inverse Laplace of 2 over s plus 2 squared plus 4. So now, if I glance at this, I say, okay, my f of t is going to be twice. And what is this? If I look at, I believe it was 8. E to the opposite of that, so e to the negative 2t, the sign of 2t, oh, they match. I don't want them to match, but it's okay. Negative 3 halves. If I look at this piece, now that matches 7 identically, s minus a, and those 2 match. What do you square to get that number? Well, if you square 2, you get a 4. Again, I didn't want them to match, but they happen to be that way. So this gives e to the negative 2t, and it's going to be the sign. The 2 comes out of those. Now, you're done. Well, not really. You have to tell me, what did you use? So, for the sine, I used 7. For the cosine, I used 8. This one right here was allowed by 7, and this one here was allowed by 8. You must show me what you're using on every step of the way. And that takes care of this section.